Okay, so we are going to review domain and range, another concept from Algebra 1, but we are going to use both inequality notation and interval notation. It's an Algebra 2 standard that you can use both to represent domain and range. And so domain refers to all the x values of a graph or function, and range refers to the y values. And so when we are looking at the domain, we are going to be scanning along the x-axis. When we are talking about the range, we are going to be scanning along the y-axis. And so I'm going to use pink for domain, green for range. And so when I'm looking at the domain for number 1, as I scan along the x-axis, the very first point I get to is -5, and it goes all the way to +5. Okay, there are points on each side, and so we are going to include them when we use our interval notation. So -5 is the low point, comma, +5 is the higher point, and we use brackets for both. In inequality notation, we would do -5 to 5, and we would put lines underneath each one. When we're talking about range, we look at the y-axis. And so the very first point we get to as we scan along the y is 0 for this function. I'm going to clear that. Zero is the lowest y value of this function, and then +5 is the highest. Again, there's no obvious open circle like we see here, and so we use a bracket instead of a parenthesis. So 0, 5, bracket. And if we use the inequality notation, we would have 0. This time we use y, since we're talking about range, to 5. Max and min always refer to y values. Whenever you talk about the max and min of a function, you're talking about the lowest output and the highest output. And so max would be this point here, and then min would be this point here. Okay, for number 2, I am in domain mode first, so I'm going to switch to pink, and I'm going to scan from left to right. And so as I scan from left to right, the very first point I get to is -2 for the low point and 6 for the high point. So -2, comma 6. Since there's an open circle at this -2, I'm going to use a parenthesis. Since there's a closed circle on the 6, I'm going to use a bracket. So that's interval notation. For inequality notation, -2 to 6. 6 gets a line, -2 does not. Switching to range, I'm going to clear my graph. Scanning from bottom to top, because we want to go low to high, -4 is the first point, and then the highest point is +2. So -4 to +2. The -4 has a closed circle, so bracket. The +2 has an open circle, so parenthesis. The max would be 2, and then the min would be -4. And I'm not going to write the max because there's a parenthesis here. Anytime there's a parenthesis, meaning you had an open circle, that means you don't get to include the 2. And so the maximum does not exist. D and E for does not exist. Anytime you have an open circle where the maximum should be, you're going to say does not exist, because you can get infinitely close to this maximum number but never actually reach it. So if you said 1.5, I could say 1.9. Then you could say 1.99 and so on. So we can get infinitely close to it. And so you can always get closer, you can always get higher, but you can't actually reach the 2. And so this would be a situation where you have does not exist. Okay, I'm going to leave number 3 for you to do. A lot of people get confused by number 4, so I do want to go over number 4. Domain. Scanning from left to right, -7 is the first point, 7 is the second point, the higher point. And so -7 to +7. And then we want to use brackets for both because there aren't any open circles. Here we have a very obvious open circle. If you do not have an open circle, you include it. And so in inequality notation, we would have that. Switching to range, same deal. We scan from bottom to top. The first point is -7. The higher point is 7. So the range looks exactly the same, except when we use inequality notation, the variable is being used, and so we see a y instead of an x. Okay, the maximum, both of them exist. The maximum would be 7, the minimum would be -7. Okay, number 5 is our first example that does not have any bounds. There's an arrow showing that it keeps going. And so even if that arrow wasn't there, if it falls off the graph, we assume it keeps going, but we'll try to be very clear on a test or quiz. And so for domain, switching to pink, as we scan from left to right, this function is going up forever, but it's also going to the left forever. And so this function is going off to -infinity, and then it's going to the right forever, so to +infinity. So the domain here would be -infinity to +infinity, which we know as all real numbers. So for inequality notation, we'll just do that fancy R for all real numbers. For the range, as we scan from bottom to top, we do have a bound here. Its lowest value is 0, but this function goes up forever. And so it's going up to +infinity, whereas -infinity would be down here. And so when we're talking about our infinities, -infinity is to the left when you're talking about domain. It's to the bottom when you're talking about range. +infinity is to the right when you're talking about domain, and it's up when you're talking about range. Okay, so for our range, our lowest value is 0. Our highest value, it goes forever, so positive infinity. We want to put a bracket on the 0 because there's not an open circle there. And then infinities always get a parenthesis. This is another situation where our maximum does not exist. You cannot use infinity as a maximum. So this would be another situation that you can always get higher than whatever number you give me. So we're going to say D and E for does not exist, but the minimum does exist, 0. Number 6, I'm going to leave it blank because the answer ends up being exactly the same as number 5, but I will let you fill that in on your own. The last one I want to do with you is number 9, because this is our only example on this page of discrete data. And so that's hard to see. Discrete versus continuous. Discrete means disconnected, just isolated points. Continuous means connected. Disconnected, connected. And so every other example on this page has been continuous or connected, meaning we can draw the whole graph without picking up our pencil. That's why we have to use either interval notation or inequality notation, which I forgot for this case. Y is greater than or equal to 0. Because you can't list all of the points here. There's an infinite number of points with continuous data. For number 9, this is not continuous, so with isolated points, you can't use these intervals and inequality notations because you don't have all of the points in between, and you don't get to connect them, so don't do that. And so domain and range becomes even easier in that case because you just list each x value and list each y value. So continue scanning from left to right, bottom to top to write these values. It'll help. And so here's -1, -2, -3, -4, -5, -6, -7, -8. Okay, and so for domain, we're scanning from left to right, so our first x value is -8, followed by -4, followed by 0, followed by 1, 2, 3, 4, 5, 6, 7. Oh, that's 2, sorry. 2, 3, 4, 5, 6, 7, 8. 2 and 8. And so this is what is called roster notation. You do a squiggly bracket and list them from least to greatest. So we would start with -8, followed by the -4, followed by 0, followed by the 2, followed by the 8. And try to have tunnel vision from left to right. You don't want to accidentally list a y value. That's x is -8, x is -4, x is 0, x is 2, x is 8. We're going to do the exact same thing for the range. This time you want tunnel vision from bottom to top. So we have -3, -2. I'm going to go ahead and start writing these down. We have a 0 right here. We have a 2, a 3, 4, and a 5. Just listing the y values. Okay, and so we can still talk about a max and a min. It's still going to be your lowest y value and your highest y value. That's why I scan from bottom to top. -3 is the minimum, +5 is the maximum. The last thing I want to talk about on this worksheet is function versus non-function. There are two examples on here that are not functions because they fail the vertical line test. Number 4 and number 9. Anytime an x value has two different y values associated to it, it's a non-function. Because it fails a vertical line test. And so number 9 fails the vertical line test because x = 2 has two different outputs. So that is another non-function. Okay, so for your notes, I want you to fill in number 3, 6, 7, 8, and I will finish this and post the answers.